Hello and welcome. In this video, we are doing question 6A from the IEB supplementary exam of 2021. The question reads, given a set of natural numbers up to and including 900. So basically 1, 2, 3, 4, 5, 6, 7, all the way to 900. Now they say, if the multiples of 5 are removed from the set, determine the sum of the remaining numbers. Okay, so we have the set of just the natural numbers 1 to 900, and we imagine that we remove the multiples of 5, and then we have to determine if we add up the remaining numbers, what would be the sum? So this is a question that most people would understand what it's asking them. Understanding is one thing, but knowing what to do and then knowing how to approach it is another thing. So I think the English is quite plain. We can understand what is happening here. We've got the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, all the way to 900. And we're being told numbers like this, multiples of 5, are removed. 15 will be the next to be removed after I remove the 10 and the 20 and the 25 and the 30, right? So those numbers are removed from this. And then we must figure out the total of the remaining numbers. Well, I mean, the remaining numbers don't form any sort of pattern that you can understand if you look at it, because you'd have the 1, 2, 3, 4 here, and you'd have 6, 7, 8, 9. I mean, this jump that happens here, the remaining numbers sort of is a pattern that is not something we can understand. It's not an arithmetic pattern. It's not a geometric pattern. It's not a quadratic pattern. And those are the only three patterns we've studied. So then it sort of causes a problem there. So the approach would be better off if we find the sum of all 900 numbers before we remove the multiples of 5, and then find the sum of all the multiples of 5, and then minus that sum from the total sum, and that should give us what we're looking for. Okay, so that's a lot of talk. I think it's now the time that we do this. So let's find the sum of all the numbers. That's our first objective. Let's find the sum of all the numbers, which all the numbers are just basically an arithmetic sequence with a difference of 1, because it's 1, 2, 3, 4, 5, whatever, and it's just an arithmetic sequence with a difference of 1. So if you want to find that sum, you could just do the arithmetic sum formula, which you're lucky because you even know the last term, which is 900. So we may use this formula that has just a plus L, and we would then say S900 is the same thing as 900 divided by 2. A is 1 because it's the first term, and the last one is 900. This should give us the sum of all, sorry about that. This should give us the sum of all the numbers from 1 to 900. And if we type this up in a calculator, we would end up with 405,450. So that's the sum of the first 900 natural numbers. Okay, but we still have to minus, the sum of the multiples of 5, because those are removed from the set. So let's do that maybe with the color green. Let's start by just analyzing the multiples of 5. All right, so these are the multiples of 5. And let's say if we were to sum all of this, what would be the last number divisible by 5? Well, clearly the 900 should be the last number because 900 is indeed divisible by 5. Before the 900, of course, you would have had 895, but I don't need to write all the numbers, so I'm just going to write this, and at least the last one I know is 900. Okay, so then I can say, in this situation now, I need to find the sum of these numbers. And then if I have the sum of these numbers, then I can minus it from this total sum. Then I'd have the what I'm looking for actually. But to do that, I'm going to need to know how many terms I have in here. And I can quickly do that just using the Tn formula, where I know Tn is a plus n minus 1 times d. Tn would represent the last term. The first term in this case is 5 plus n minus 1. D is obviously 5 because you're moving up by 5 each time. So then you could minus the 5 and you've got 895, and that's equal to 5n minus 5. Um, and you would add the 5, and you're back again to 900 equals to 5n, and n is basically 180. Okay, so you know now that there's 180 terms in here. This helps you to be able to do your SN, which again we could use the same formula because we know the last term. So we're just going to go A plus L, um, and S. The only reason we needed to do this first is to know what S are we going to calculate. It's S180. So, if we didn't know how many terms, then we wouldn't know what n is. So that's why we needed to do this first. So we now know what n is, and we can continue with this. So this is now divided by 2. A is 5, and L is still 900 in this case, and S 180, if you type that stuff up in a calculator, you should be ending up with 81,450. Now, take that sum of every single number and minus the multiples of 5, the sum of all the multiples of 5. And so then you would be finishing up your question. Therefore, remaining, that's not the word that I'm trying to write, numbers remaining numbers sum is the same as this number over here, 405450. So it's 405450 minus the 81,450, and once you calculate that, that is 324,000, and that is how you would have answered this. So this was 7 marks. Can you believe this? This is 7 marks, and it's really not that hard. It's really just thinking about an effective way to approach this. And I do hope that by watching this video, you've learned a strategy or two to deal with sometimes a series that will be given to you, and then maybe some terms are removed and whatever. And you got to be strategic about that because those types of questions will come up every now and then. So thank you so much for watching, and I look forward to see you in the next video.